Hello and welcome back to Chapter 3. Last night I recorded a Mondo lesson. It was huge. 4 lessons in one sitting. This morning when I woke up I thought, you know what, I can't do that. That's not going to be nice to you guys. So we're splitting it in half. Now, this these notes take care of 3, 4, 5, and 6 of Chapter 3, but we are only going to be doing adding and subtracting of like and unlike denominators today. That would be lessons 5 and 6. We are going to save multiplying and dividing lessons 3 and 4 for Monday. So you will have a lot less work than I had planned for you last night. So here we go. Let's get into it. Our first thing that we're looking at is adding and subtracting with like fractions. Now you're very familiar with this from elementary school as far back as possibly 3rd grade, maybe 4th grade. And so it gives you, I have it in the notes here, an example with variables. If A over C is adding to B over C, you notice that the denominators are the same. When the denominators are the same and you are adding and subtracting, then that means you are adding and subtracting like fractions. And that makes it easy. All you do is you bring your like denominator over here, and then you add the top. A plus B is A plus B, and that is your answer. Now this only works when C is not equal to 0. Your denominator cannot be 0. And hopefully some of you guys asked that during the lesson today. You might say, hey, wait a minute, I thought you could do like 5 divided by 0. That'd be 5 over 0. I had news for you. It's never been that way. 5 divided by 0 has never been 0. Okay, so let's get into the notes here. First of all, we're going to do this one right here. Write all fractions, write all mixed numbers as improper fractions. Let's talk about what that means. Let's take for example, 3 and 1/4. Okay, 3 and 1/4. Now, how do I do it? I was taught this way. I start at the bottom with the denominator. I multiply it by the whole number. So that's 4 times 3. And then I add the numerator. I kind of go in a clockwise fashion. So I start with 4, multiply the 3. I get 12 plus the 1 is 13/4. That's called an improper fraction. Now, there's other ways to think about this. What are we doing here? Well, we're taking 3 whole numbers and adding it to a fourth to make 3 and 1/4. So another way to do this would be, what is a whole number with a denominator of 4? Well, 4 over 4 is a whole number. Plus 4 over 4 plus 4 over 4. So what did I just do here? I just took the number 3 and made it happen right here. This is 1 plus 1 plus 1, which is 3. Now I have one more thing to add. What am I adding? This last 1/4 here. If I add up all these, since they all have the same denominators, 4 plus 4 plus 4 on top is 12, plus this one is 13/4. That's a longer way to go, but it's showing you that what we're doing here. What are we doing? We're doing 3 of the 4s. 3 times 4. You can see it right here. 1, 2, and 3. Plus the 1 left over right here. All right, number 2. Add, subtract the numerators and keep the common denominator. And then finally, always simplify. It says if needed. If you don't simplify on a test, quiz, or an assignment, and you get your results back on a Google form for an assignment and you have it wrong, but you believe you did it right, check that to make sure that you simplified. All right. So I have some examples here, and let's start these. The first example right out of the box is subtraction, and we learned back in chapter 2 about the additive inverse. I'll write this here, additive inverse property. And we learned that when we use the additive inverse property, it takes subtraction problems and it makes them into addition problems. So let's use that right now. We see a subtraction sign, so we're going to do additive, and then this is a positive 3/10, so we're going to make it a negative 3/10. Notice that I put the negative at the top. There's a reason why I do that. Okay, I'll have a little timeout lesson right now. Over here on the side here, I can do negative 3/10. Well, negative 3/10 is the exact same thing as negative 3/10. See, the negative sign is in the middle. Oops, that is not the right number on the bottom. Tenths. Okay. Now, I can also make the sign go down below like this. That is also the same number. And if you look carefully, this is negative 3 divided by 10, which gives you a negative answer, right? A negative divided by a positive is a negative. And this one is a positive divided by a positive. And once you do that, then you apply this negative sign to it. So that still is a negative problem. And this is a positive 3 divided by a negative 10, and that still is a negative. So what I'm showing here is all of these are the exact same number. You can make the negative sign go high, in the middle, or at the bottom. I prefer going high. All right? It's going to be a lot easier for you if you do it, if you adjust it to the top. Do not, under any circumstances, apply a negative to the top as well as the bottom. Why? Because when you go negative 3 divided by negative 10, you guessed it. What do you get? You get a positive. Okay? All right. So that was your little lesson. Refer back to that often if you need it. Back to the problem. We notice that the denominators are the same, so we're going to go ahead and go 10. And then 1 plus negative 2 is, sorry, I said the answer. 1 plus negative 3 is negative 2. And that can be simplified. So we notice that 2 can go into both. And negative 2 divided by 2 is negative 1. And 10 divided by 2 is 5. And that's our answer. Moving on over. Now we have an addition problem. And up there it says change your mixed numbers into impropers. So 4 times 3 is 12, plus the 3 on top is 15 fourths. Notice that this originally was a negative answer, so keep it negative. And this is negative 25 fourths. I floated the negative sign up to the 25. The denominators match. And negative 15 plus negative 25 is negative 40. And I can simplify that. Negative 40 divided by 4 is easy. Negative 10. Here's another one. Deal with the mixed number first. So 11 times 1 is 11, plus 8 is 19 elevenths. 11s come on over. Negative 3 plus 19 is 16. 16 elevenths cannot be reduced. I am not going to change it back into a mixed number. I can leave it as improper as long as the improper is totally simplified. It cannot get any smaller. And there you go. 3 more for practice. Additive inverse. All right, change this into a improper. This is 12 plus 3 is 15 fourths. The 4 carries over, and negative 15 plus 25 is 10. This can be reduced. And 10 divided by 2 is 5, and 4 divided by 2 is 2. That's simplified. Additive inverse. Change this one here. It's going to be 19 elevenths. And this is now going to be 22 elevenths. 22 elevenths can be simplified to 2. And now for a fun one, we use parentheses because we're using the substitution property of equality. And what's my a value? My a value is negative 3/8. I'll float the negative sign up. B is 7/8. I'll use additive inverse, additive inverse. And then we begin. We know the denominator is going to be an 8, and negative 3 plus negative 7 is negative 10. This can be reduced. Negative 10 divided by 2 is negative 5, and 8 divided by 2 is 4. All right, that takes care of the like denominators. Now we're going to go to the unlikes. And I unlike these personally because you got to do a little bit more work. All right, but let's learn how to do it so we get the right answers. This one is the same as above. Mix, right? You mix numbers into impropers. This one's different. You got to have a common denominator. Okay, that's called the what? LCD from elementary school. Least common denominator is the best way to do it. You don't have to have a least, but it works out best for you if you have the least. And then rewrite the fractions using the LCD as a denominator. This is a new piece. And then add, subtract the numerators and keep the common denominator. That's what we just did in the like fractions, and simplify it. That's what we did in the like fractions. So you have two additional things you got to watch out for here. Let's look at this mess of numbers that I have. All right, this is AB fraction plus CD. Notice that the denominators are not the same. So we need to make them the same. So one way to do that is you multiply b times d. Now you can see a over b is being multiplied by d over d. D over d is equal to 1. So you're not going to change the value of a over b. All right? And I'll do the same over here to c over d. I'll multiply it by b over b, which is 1. I'm not going to change the value of c over d. Okay, so when I do this, a times d, I'll do this one right here, is now right here. A times d is AD, and B times D is BD. I'll do this one. C times B is BC. I turned it around so they're in alphabetical or variabetical order. And D times B is BD. I changed it around using commutative property like I just said on the top. So this is done. And notice right here that the denominators are now the same. Now I can add the numerators. AD plus BC is AD plus BC. See how that happens? And I just bring the denominator over. Now this only works when B and D are not 0, just like I mentioned on the top examples. All right, we have 6 of them to do here, so let's do this and then get you underway. The first one's addition. We notice that the denominators are different. So to handle the denominators being different, we want to do it a couple ways. Now, your elementary school, most likely you probably had something like this is, I'll do it with a negative number. Remember, I like to float the negative to the top, and then this is 1/6 down here. Something like this. Probably had an addition sign here. And then a lot of teachers would do it like this. Stack them up. This is just one algorithm to solve. There's many others. And so you're going to say, well, what does 6 and 9 both go into? And then when you studied the LCD back in elementary school, you probably lined the 6 and the 9 up, and then you counted by 6s, 6, 12, 18, 24, and kept on going. And then you counted by 9s, 9, 18, 27, and you're looking for the least common. Well, we have 18 is common, and that is the smallest number that they have in common. So that's what you would use. 6 times 9 is 18, and so we need to put a 9 up here, and this represents the number 1. And could you figure out what property this is right now that we're using? 1/6 times 1 is itself, correct? Yeah, that's the identity property of multiplication. So 1 times 9 is 9. 9/18 is exactly equal to 1/6. It's the same number. Now go to the top. 6, that's 1. -5 times 6 is -30. I made an error. Let me back up. Made a lot of errors here. Backing up. Okay. 6 times what equals 18? 6 times 3. I apologize. 1 times 3 is 3. And 9 times 2 is 18. That's 2. -5 times 2 is -10. So now we just add these up because they have the same denominators. And -10 plus 3 is -7. Okay, so that's how you would do it in elementary school. All right. Now I do it a little bit differently. I don't stack them up and stuff. I don't do all those things. Got to do a lot of things in my head. So I have 18 and 18. And then I would go 6 times what equals 18? That's 3. 1 times 3 is 3. And that's 2. So that's negative 10. That's how I do it. Make sure it's simplified, and it is. Next one. 8 and 20. 8 can't go into 20, so 20's got to go up one more to 40. 8 can go into 40, so that's my LCD. 8 times 5 is 40, so 5 times 5 is 25. 20 times 2 is 40, so 1 times 2 is 2. Float this negative sign up. And 25 plus negative 2 is 23. And that is simplified. I have to change this mixed number into an improper. So this is 6 plus the 1 is 7/3. And 14 plus the 1 is 15 seconds. Make sure that this was originally a negative, so keep that negative there. So same thing with this one. If it was originally a negative number, don't change the value of it. It's negative. All right, so now I need to change my denominator. So 6 is the LCD here. 3 times 2 is 6, so 7 times 2 is negative 14. 2 times 3 is 6, so negative 3, or negative 15 times 3 would be negative 45. And negative 14 plus negative 45 is negative 59. Now that is totally simplified. That's the answer. 3 to go. I see a subtraction sign here, so you guys know what you can use. Additive, inverse, additive, and then inverse of 5/9 is negative 5/9. All right, so 7 and 9, so I think 63 is my number to use here. 7 times 9 is 63, so 3 times 9 is 27. Keep that negative sign. 9 times 7 is 63, so 5 times 7 is 35. Keep that negative sign. 63 is my denominator, and negative 27 plus negative 35 is negative 62. Now, some of you might start using a calculator on some of these. I had to use a calculator for this and this. All right, my brain could not compute it fast enough because I had to carry the ones place to the tens. All right, going on to this one. Additive inverse. Change these into improper fractions. 8 times 6 is 48, plus the 3 is 51/8. 2 times 12 is 24, plus the 1 is 25 seconds. 8 is my LCD. 51, that will stay the same. This is 2 times 4 is 8, so 25 times 4 is 100. And that's going to be 151 over 8. Now, you got to think about all the numbers that can go into 8. Those include 1, 2, 4, and 8. Well, 1's not going to simplify this. 2 is not going to work because 151 is an odd number. And same with 4 and 8. 151 is not divisible by any even numbers. So this is simplified. And the last one, using substitution property, we always use parentheses. And it's coming clear why we do this, so make sure you use them. R is 7/8, and D is negative 3/5. We use additive inverse, and now we are going to make like denominators. 40 is our number. 5 times 8 is 40, so 7 times 5 is 35. And 5 times 8 is 40, so 3 times 8 is 24. Add those together. 59/40. And can it be simplified? It cannot, so that is the answer. All right, that concludes our lesson. Now, let's get down into the practice problems. At the notes here, you notice that we did the I have it jumbled up. So 5 and 6, less than 5 and 6 are at the top. If you scroll down lower, this is going to be what we do on Monday. Okay, and I will release that video on the weekend so you have some extra time for it. So skip those now. And then I shifted 3-5 right here. You see it? Less than 5 right here. And then right below that, I have 3-6. This is right here. These are the two that you are working on today. Lower, well, there's this thing out to the right here. Disregard that. Okay. Lower, down here, we have 3-3, less than 3, and we have 3-4, less than 4. Okay. So you don't have to do those today. That's multiplying and dividing rational numbers, so don't worry about those. We are concentrating on lessons 5 and 6. And usually, make sure you really make a note in your brain here. Usually I have you do the evens. That's not the case because look how many evens there are. So I'm having you guys do all of the multiples of 3. That's 3, 6, 9, 12, 15, 18, and 21. And then you move down to this one, and same thing. 3, 6, 9, and 12. And that's it. So how many is that total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 problems for your work. It was originally going to be 26 problems. So that's why we're splitting it. It's a little too much. All right, let me give you some examples here on this one. Notice this is a pretty easy one. You can look back at the notes for that one. I don't think you're going to have much issues with that. Just when you get to it, make sure you what? Simplest form. If you don't do simplest form, you're going to end up not getting the point for it. I'm stressing that on you guys. Make sure you use simplest form. All right, number 6 has like denominators. Let's find one that looks like number 6. Look at number 8. This looks like it. So what I would do here, I would do additive inverse. All right, now we're all matching. I would float this up to the top. And so this is going to be 14 as my denominator, and -3 plus -5 is -8. It's not bad, huh? Easy. Okay. Then number 9 has a mixed number. You got to change that first, and then go for it. Let's do 15 because that's got some fun stuff in it. 15. Number 13 looks like number 15, so I'll do this one. So additive inverse, float this sign up to the top. 11 is my denominator, and -5 plus -2 is -7. So I think you'll be good with those. If you need more examples, you can ask in class. We have plenty more here that I can show you examples on the whiteboard during Zoom. All right, let's go down to this one right here. This is evaluate expressions. That means to solve it. So you need to enter these into the problems. So you can see that 18 is y minus z. All you have to do on 17, as an example, you would do parentheses minus parentheses, and then do your substitution property. X is 2/5, y is -1 and 1/5. So I'll use the additive inverse here, additive inverse, and then I'll change this mixed number to an improper. 5 times 1 is 5, plus the 1 is 6/5. That's going to be 8/5, and that's in the simplest form. So be careful with those, with your signs, your substitution property, all those things. Coming on down here, this is the harder part of the lesson because it doesn't have like denominators. But from elementary school, I'm sure that you guys are professionals on this. If not, just ask the question. I want you guys to ask. You need to know how to do this. Some students think that changing all fractions into decimals is the way to go, but it is not, because you're going to start dealing with repeating decimals, and you can't, there's no way to do it. All you can do is estimate. Keeping things in fraction form, you'll get the exact answer every time. All right, so let's see. Number 3, you'll have to do additive inverse first, and then get your like denominator. Let's see. 14, number 6, you're going to have, that's a big one. You're going to have to find your like denominator there. Using a calculator to find that like denominator might be the way to go. And same with number 9. I'll do number 7, kind of show you guys a spot here. Okay, so 7's a big one. It's addition, so it's easier. It's no additive inverse stuff going on. This is negative. Oh, I don't want to put that yet. I need to find a like denominator. Nope. I need to change this into a mix, all right, improper fraction. 12 times 1 is 12, plus 5 is 17 twelfths. And that's a negative, so keep it negative. Now I'll look for my like denominator. 24. That wasn't so bad. 8 times 3 is 24, so negative 3 times 3 is negative 9. Keep it it's originally negative, so it should be a negative still. And this one is 2, and 17 times 2 is 34. I go ahead and add this up. 9 plus 34, for me, that's a calculator job. That's negative 43. I look to see if I can simplify it, and I cannot, so that is the answer. On number 12, you're going to do additive inverse, change both to improper fractions, and then make your like denominators. And finally, oh no, that was it. That was it. Okay, so there's lots of extra problems I can use as examples. If you need them, just ask and we can work on those. Remember, only do the multiples of 3 on the assignment.